continuing CO5 scientific notation. Still don't know why I'm teaching this in math class, but I am, so here we go. We filled out how many feet the sun is away from the earth. We talked about this yesterday. I just want to recap quick, because this is kind of, if there was like one key point to this whole thing, it's these two questions here. Understanding what a positive power means versus a negative power. So what were the two things that we wrote for what a positive power represents based on what we had in the above examples here? Yeah, Eddie.
It was a big number.
Big original number. Remember, scientific notation, its purpose is to have another way to write really big and really small numbers.
Yeah.
Right? Especially ones that contain a whole bunch of zeros. And Eddie, what was the other thing?
The decimals moved to the right.
Okay. To get that big number, when we're going from scientific notation back to what's called standard form, which we're going to practice today, the decimal moves to the right. How about a negative power?
Well, I was just going to ask a question.
Yeah.
Why do they have scientific notation if you can just write the number verbally? Like, a billion has a lot of zeros, but you can just write B-I-L-L-Y-O-N.
Sure. It's just another way to do it. There are ways that you can use operations with scientific notation too. Like if you have two distances, like the distance between the Earth and the Sun and the Earth and Pluto, right? And you want to add those distances together. You can add values using scientific notation. You can also subtract values, you can multiply, you can divide. So there's operations you can do with the two. We're not going to get into so much of that. But because you can do mathematical operations with these numbers as well, that's why we use it. So, but good question there. What does a negative exponent mean? Negative exponent, go on. Small number. And that means, to put it back into standard form, the direction you move the decimal point is to the left. Okay.
Left.
Decimal moves left. Okay, so let's practice here. In the above examples, we went from standard form to scientific notation. Here we're going from scientific notation to standard form. So 7.613 times 10 to the fourth. What this means is that we are multiplying this number by 10 4 times. Another way to think about this, you don't need to write this down specifically, but another way to think about this is we are multiplying by 10 4 times. That's what times 10 to the fourth means. We're multiplying this number by 10 4 times. And every time we multiply something by 10, what happens to the decimal point? It goes one spot to the right. That's why this exponent tells us how many times taken to move the decimal spot, or the point, to the right. So 7.613, 1, 2, 3, 4. What do we add there between the 3 and the points to get our original number back? A 0. So our original number was 76,130. Okay? 6.8 times 10 to the 10th, I'm not going to write this out, times 10 times 10 times 10. But again, what this is saying is that we are multiplying 6.8 by 10 times. Which means how many times will the decimal get pooped over to the right? 10 times. Okay? So, I'll do it in red so we can kind of differentiate it from the green here. 6.8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We fill in all these little spaces here with zeros. You got to write a little bit small here, otherwise you're going to run out of room. So we have 6, 8, and 9 zeros. Put commas where we need to. 68 billion is our answer. What would you guess the most common mistake that folks make with scientific notation would be? So you got to guess, Henry.
They would put the number for how many zeros there were. They would just count the zeros.
Yeah, the biggest mistake that folks make is they'll write 7613 and then put 4 zeros after that, making the number much bigger than it should be. There's only 1 zero because we had to move 3 times to get to the end of the number. One more hop is why we got the zeros. So the number, the exponent is not how many zeros there are. Okay, not how many zeros there are. The exponent is how many times you move the decimal. 5.1973 times 10 to the 7th. This literally means we are taking 5.1973 and dividing by 10.
Why aren't you using the slash?
I could. I'm not, but
It sounded cool when you wrote it.
Funner to do that.
very rhythmic. ASMR, right?
Yeah, it's smart.
I actually tried to start an ASMR channel. Always soothing math recordings. But never really took off the ground. Yeah, never off the ground. I have no trouble with my regular YouTube channel. I can't get to 300 subs.
What's it called?
Always soothing math ASMR, Kevin Schultz ASMR, soothing math
Oh,
recordings.
boy.
Remember that when I tried my ASMR YouTube channel?
Your what?
My ASMR
Is
YouTube
it
channel,
deleted?
always soothing math recordings.
That was a thing?
I tried to make it a thing, it didn't quite
Did you
take
just
off.
try it again?
Is it still?
Like,
We should all
Did you delete
subscribe
it?
to us for
you can,
both.
if you are pressing calculator buttons, that could be very rhythmic, very.
Go with the Wayback Machine. Well, that means that someone had to document.
We're all wild here.
Yeah, so it
How many seconds is in a day?
Okay,
was.
anyway, so,
81 multiplication.
folks, 3, 2, 1, 5. Every time you divide by 10, what are you doing to the decimal point? Moving it to the left, okay? Just like how multiplying by 10 moves the decimal to the right, division means the opposite, dividing by 10 moves the decimal to the left. So that's how many times, starting with 5.1973, 1, 2, 3, 4, 5, 6, 7. Not only do we fill in all these empty spaces with zeros here, but we've got one out in front also to show that there are no holes. So our answer would be 0.00000051973. A very, 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 very small number. Grace?
Instead of drawing those wavy things first and then putting the zeros in, I'll put like an estimate of how many zeros I think will be there and I'll add more.
You do you, man. Yep, this is just to show you what's happening. If you got a way that kind of makes more sense to you, by all means, okay, do it. Lastly, 8.21 times 10 to the negative second. Again, that's how many times they move the decimal, 1, 2 to the left, 0, 0, so 0.0821 is our answer. Questions on scientific notation? It's one of those things that it's not necessarily a difficult concept, but if you start doing it wrong, it's easy to do it wrong every single time. It's one of those things where if you make a mistake, chances are you'll make the same mistake and get them all wrong, right? Or you'll do it right and you'll get them all correct. So if you've got a misconception, you've got a question, please do ask. Because I don't want you to get them all wrong. Good. Okay, your homework for tomorrow then is to finish the objective.
Where'd you put it? Oh, it's right here.
Oh, thank you. See, I lose this thing all the time.
That cheater set, whatever it's called, keeps falling down.
Hey, Owen, Rowan, in the back. Okay. Your homework is to finish the page. You've got 8 of them like we did yesterday, where you're going from standard form to scientific notation. You've got 8 of them where you're going from scientific notation to standard form. And then a word problem at the bottom. It says, at the time of this document's last edit. So the last time I edited this document, I was about 1.2 times 10 to the 9th seconds old. How many days is that? So first, you've got to figure out how many seconds is this actually, and then convert that number of seconds to days. Okay? Then some review at the bottom. It reviews objectives 1 through 4. Much like your Bellinger did today, and this is all due tomorrow. You've got 10 quality minutes to work on it right now.
This is
Okay,
copying off.
Kyle, shh, Questions, comments, concerns, complaints, comments, congratulations, criticisms. All right, now to science math.